Welcome to Ask and Learn.
We are given a non-deterministic finite-state automaton. We are asked to find a deterministic finite-state automaton that recognizes the same language as the non-deterministic machine. The machine can be found in exercise 47 of this section. So in the previous exercise, we saw the language recognized by the machine was one 0 star union 1 0 star 1 0 star. And in this previous exercise, the graph we were given is actually not far from being a deterministic graph. So we'll just adjust this graph. So we're given that S0 is a start state. And we'll want to designate S0 and we'll designate S1 and S3 to be final states. And in fact, we're going to have 4 states total: S0, S1, S2, and S3. Now, as in the non-deterministic version, suppose that our string starts with a 1, or suppose that it starts with a 0. Let's do that first. And we're going to move from S1 to the non-final state S2, since 0 should not be recognized. And once we're at S2, we're going to remain at S2. Since the string should not be recognized at all. Now, on the other hand, suppose that the first bit is not a 0, but a 1. Then we see that we'll want to move from S0, which is a non-final state, to a final state, which we could take to be S1, since 1 should be recognized. And once we're at S1, we see that there is we see that if we add any sequence of zeros, the string should be recognized, and so we'll want to draw a loop for the input 0. So suppose that the next bit is a 0, then we'll want to remain at the final state S1. And we see that also, if instead of the next bit being a 0, suppose the next bit instead is a 1. Well, we see that it kind of depends. So if the next bit is a 1, if there are no so if there are zeros, it doesn't matter. But if the next bit is a 1, then we'll want to move to another final state. So suppose that the next bit is a 1 at the state S1, then we'll want to move to another final state S3. And once we're at S3, we see that if we were to add a 0 onto the string should still be recognized. So suppose that the next bit is a 0 at S3, then we'll want to remain at S3. So we have a loop. Suppose instead, though, that the next bit is a 1 at S3. Well, to get to S3, we had to have a 1 followed by any sequence of zeros followed by another 1. So if we are to add another 1 onto this string should not be recognized. And so we should move to a non-final state that we cannot escape from, which is S2.